Picture this. You're on the brink of death, maybe a car crash, a fatal fall, or a deadly illness, and yet somehow you open your eyes again, not in a hospital, not surrounded by loved ones, but in a slightly different reality where you miraculously survived. What if every time you face certain doom, your consciousness simply jumped to the branch of the universe where you lived on? Welcome to the unsettling world of quantum immortality. At the heart of quantum immortality lies the many worlds interpretation of quantum mechanics. Proposed by Hugh Everett in 1957, MWI suggests that every quantum event, down to particles decaying or photons reflecting, splits reality into multiple equally real branches, where each possible outcome happens. Max Tegmark and others have popularized this idea, arguing that decoherence, the process by which quantum possibilities solidify into classical outcomes, prevents us from ever observing superpositions directly, but leaves behind a vast multiverse of parallel worlds. Quantum suicide is a thought experiment that brings MWI face to face with consciousness. Imagine a device that flips a quantum coin. If it lands heads, you live. If it lands tails, you die instantly. According to traditional quantum mechanics, you'd have a 50-50 chance. But in MWI, both outcomes occur. One you dies while the you in the surviving branch continues. If your awareness can only exist in the branch where you're alive, no matter how many times the coin lands tails, from your perspective, you'd be immortal. So, is there science behind this? Quantum immortality may sound like pure science fiction, but it's built on real physics, specifically the many worlds interpretation of quantum mechanics. In classical terms, we expect things to happen in one clear way. But in the quantum world, particles exist in superpositions, multiple states at once. According to the traditional view, these possibilities collapse into one reality when observed. But in 1957, physicist Hugh Everett suggested a radical idea. What if they don't collapse at all? In his many worlds interpretation, every possible outcome actually happens in a separate, parallel branch of the universe. You see one result, but there are versions of you seeing every other possibility too. Reality in this view constantly splits. This branching is powered by a process called decoherence. When quantum systems interact with their environment, the different outcomes evolve separately, never interfering again. That's why we never see superpositions, even though the math says they're there. This doesn't mean you're safe from danger. In most branches, you do die. Only one version of you survives, and it's the one having this thought right now. This raises deep ethical and emotional questions. If someone truly believed in quantum immortality, would they take more risks? Trust that they'll always wake up in a version where they made it? But in most versions, loved ones are left grieving. From their perspective, you're gone. Only you feel the illusion of never-ending survival. It also challenges our sense of meaning. If you can't truly die, what does that do to your understanding of life? Would it make life feel sacred or pointless? Scientifically, we can't confirm or deny this. The many worlds interpretation matches standard quantum predictions, and we can't observe or interact with other branches. But thinkers like Max Tegmark and Sean Carroll believe that exploring how quantum information behaves might someday help us understand whether consciousness could really ride the branches of the multiverse.